Okay, great levels. Let's look at this one. This will be question 5 of your paper 2. So, of your maths paper 2. Let's look at how to prove the identities, okay? So let's say that you are given the tan of theta multiplied by the cos of theta. This one is going to be a very easy one, maybe for 3 marks, and they want you to prove that this is equal to the sine of theta. So when you work with proving identities, I need you to check the most complicated side. So this is your left-hand side, and this is your right-hand side. So the one that is most complicated is the side that you need to work with. Okay, so I'm going to say on my left-hand side, look at this tan. We know that tan is an identity. So we can change tan. If you still remember, where there's the tan of theta, we can substitute that by the sine theta over the cos of theta. So I'm going to change that and write this as the sine theta over the cos theta. Then this is multiplied by the cos theta. So if you still remember, the cos theta is over 1. So now when I multiply the top part, this gives me the sine theta multiplied by the cos theta, and everything is divided by what? The cos theta. You're going to look at the like terms. If you have a term that is the same as the one on bottom, then you cancel the 2. Okay, so this shows that we only left with what? We only left with the sine of theta. So the final answer will be sine theta, which is equal to the right hand side. So left hand side is equals to the right hand side. And that's it for that one. That was an easy one, right? So let's say that this time let's work on this one. Even this one will be an easy one. Then we'll keep on adding more examples. So if I work on this one, let's say I have the cos of x, this is divided by the sine x, and this is multiplied by 1 over the cos squared x times the sine squared. So we need to prove that this is equals to the tan x. Okay, so when you do identities, you need to ask yourself, what is the aim? The aim is to prove that, because remember I said look at the most complicated side, which is the left hand side. So the aim is to prove that on the right hand side, the top part, we only need the sine x, and the bottom part, we only need the cos x. So this tells you that if you prove the left hand side, whatever that you do on the left hand side, the aim is to make sure that on top we only have sine, and on bottom we only have cos. So let me write this and say this will be the cos of x multiplied by 1, and this is over 1. So I'm trying to multiply the numerators because I want to write this as one fraction. So I'm going to change the sine squared x and write it as sine x times sine x. This will make sense why I'm writing that in that form. And this is over the sine x, which is multiplied by, I'll change the cos squared x and write it as the cos x times cos x. Now, the reason we are changing this is because this will be easy for you to check the common terms. Cancel those terms that are common. Cancel those terms. So you can see that we only have sine on top left, and we only have cos on bottom left. So this tells you that sine over cos is just the tan x, and that's it for this one. You can conclude and say left hand side it's equals to right hand side, and that's it. So let's work on the example where you'll have to prove both sides, left hand side, and you'll also be required to prove the right hand side. So if I look at this, let's say I have the cos of to the power 4 beta, and this is divided by the sine to the power 4 beta, then the cos squared beta over the sine squared beta. So this is equals to 1 over the sine 4 beta with minus 1 over the sine squared beta. So when you look at this question, I think you can agree with me when I say both sides are complicated. The left-hand side is complicated, even the right-hand side is complicated. So we need to solve both of these sides. So I'm going to start with my left-hand side. Left-hand side, I'm going to rewrite my left-hand side. This is the cos to the power 4 beta, and this is divided by the sine to the power 4 beta. We minus the cos squared beta over the sine squared. Okay, so now when you work with fractions and you are proving identities, make sure that you combine those two fractions into one fraction. How can we do that? We need to find LCD, the lowest common denominator. So your LCD, it will be, for example, let's say that I have 1 over x squared and then plus 1 over x, and I ask you what is the lowest common denominator. So you're going to choose, since both of the variables are x, you choose the one with the highest degree. So your LCD, it's just x squared. So this tells you that here your LCD, it will be the sine to the power 4 beta. I hope you understand how we got that one, right? So now that you have your LCD, you're going to take this LCD, you multiply every term there by that LCD, then you divide everything by LCD. Let's work on that. So this will be the sine to the power 4 beta. We need to take this, multiply the first term, which is the cos to the power 4 beta, and this is divided by the sine to the power 4 beta, close the bracket. Then I think we made a mistake here. This is not a negative, it's a positive. So I'm gonna bring the positive down there. Then I take my LCD, I'm gonna multiply that other term. Okay, nice. So when you're done, make sure that you divide everything by that LCD. Okay, so when I look at this, I know that this and that will cancel, which gives me the cos to the power 4 beta plus. So if you look at this, this can be written as the sine squared beta times the sine squared beta, so that one sine squared beta can cancel with that sine squared beta. Then the one that is remaining, this one, you're gonna multiply it with that cos squared beta. So when you multiply the two, it will give you sine squared beta. So this will be the sine squared beta, then times the cos squared beta, and everything is divided by the sine to the power 4 beta. So I can see that on top, I can still have the, I can still take out the common factor on top, which is, look at this, cos. So the one with the lowest degree, it has to come out as a common factor, which is the cos squared of beta. Then I'm left with the cos squared beta, because when I multiply the two, I need to get cos to the power 4. Then plus the sine squared beta times 1, because where there's cos squared beta, since it's our common factor, we replace that by 1. Divide this by the sine to the power 4 beta. Wow, this is nice. Look at what we have inside the bracket, okay? So we know that sine squared beta plus the cos squared beta is 1. That's an identity, right? We can substitute that by 1 and write this as the cos squared beta into 1 over the sine to the power 4 beta, which is the same as the cos squared beta over the sine to the power 4 beta. Right, so let's try and see if we can prove the other side. I want us to try and see if we can prove the other side to be equal to this. Let's go and work on that. Okay, I'm going to rewrite my right hand side. This is my right hand side. It's equals to 1 over the sine to the power 4 beta with minus. So if you look at this, I think you can see that we are working with two fractions. The aim is to make this to be one fraction, but the aim is to have cos beta on top and sine to the power 4 on bottom. So let's work on that. So my LCD, you take the one with the highest degree, which is the sine to the power 4 beta. Then you repeat the same process that we did here. You take the first term, you have to multiply that first term by your LCD. So this is 1 over the sine to the power 4 beta. Close the bracket, you bring down the negative. Then you take the sine to the power 4 beta. You're going to multiply that by 1 minus the sine squared beta. Okay, then divide everything by LCD. Right. So now, when I look at this, these two guys cancels. Therefore, I'm left with 1 minus. And remember, I think you still remember that this one here, we can write that as the sine squared beta times the sine squared beta, so that 1 can cancel that. Then we left with 1 times the sine squared beta, which is just the sine squared beta. So I'm just going to write this down. It's 1 minus the sine squared beta over the sine to the power 4 beta. Right. So you can see that we can change the top part and write it as cos squared beta, because this is an identity, right? The very same identity that we used here. We are saying that the cos squared theta plus the sine squared theta, it's fine, even I use theta, it's 1. So therefore, if I bring the sine squared this side, I'll have the cos squared theta to be 1 minus the sine squared theta. So this tells you that where I see 1 minus sine squared beta, I can replace that by what? The cos squared of beta over the sine squared, the sine to the power 4 beta. Therefore, left hand side is equal to right hand side. And that's it for this one. I hope you guys had a understanding of how to prove identities. I hope you guys enjoyed this lesson. If that's the case, if you really enjoyed the lesson, make sure that you join the family, subscribe to the channel. Also, leave a comment. Tell me what you want us to do next. Thank you guys for watching.